We begin where we left off last time. The mass of a quark is basically the calculation or the amount of stuff, matter, that is inside of a quark. So the next little word we're going to be diving in a bit deeper with is charge. In physics and with quarks, charge basically means when there is more protons than there is electrons, or vice versa, more electrons than protons. Now, that definition is for atoms, when atoms have more protons than electrons. But what can we say for quarks? Because quarks have a charge. It is scientifically proven with numerical evidence that quarks have a charge. Well, how is that possible? Because when there is a charge in physics, there is more of one thing than another thing inside a thing. Basically, protons is one thing, electrons is the other, more protons than electrons inside of an atom. So does this mean that there is something inside of quarks? I mean, I can be completely going off the deep end, the complete opposite direction with this little theory, but does that mean that there is something smaller than quarks? Think about it. The final one of those three words that I said earlier on in the video that I'm going to be explaining or diving in a bit deeper into is spin. When we're talking about spin for a quark particle, let me just give you a little visual. So let's say that this little hole right here is a quark particle, okay? The axis, which is what it spins on, the axis goes right through the middle of the quark. Right through the middle. So since the axis is right in the middle of the quark, this would basically mean that if the quark spins to the left, the quark would move up. If it spins to the right, then the quark would move down. So remember earlier when I said there are three quarks in protons. This guy is totally wrong. This guy does not know anything about particle physics. You are wrong. Don't you get it? You're wrong. Two down quarks. Don't you know? And one up quark. He's totally wrong, right? Totally. Well, that was actually a mistake. See, quarks do make up protons and neutrons, and protons and neutrons do have three quarks in them. Sort of. They have three valence quarks, or valence quarks. Now, this basically means that these three quarks are also accompanied by a range of other quarks and their anti-quarks. That's when you guys probably don't know anti-quarks. So let's discuss this new term, this new word, anti-quarks. Well, an anti-quark is pretty simple. It is the opposite of a quark. Opposite of the quark. That's pretty much as simple as the definition could get. So there is another little particle in the protons and the neutrons and all the subatomic particles. It is called gluon. This substance, this particle, basically acts like glue. It links the quarks together. You see the little blue, green, and red circles, those symbolize quarks. The little zigzag, little squiggle between them is gluon. I'd like to wrap up this episode with a couple of fun little, just whatever random facts about quarks. Let's do it. Did you know that the top quark has a mass that is greater than the entire atom of gold? Do keep in mind, though, that let's say a gold atom would be this size, okay, about this circle here, and a quark, the top quark to be exact, well, let's say it's about the relative size, this is very rough, of this blunt pencil, the tip of this blunt pencil. That's about the size comparison, relative size comparison, of an atom to a quark. Did you know that the mass of any quark has not yet been definitively proven or calculated? Because the quark is never found alone, it is very, very hard to calculate the mass of just one. And finally, Did you know that quarks have colors? Sort of. They don't have actual visual colors. Like, there is no such thing as a colored red quark. Color is just used as an analogy, like a way to describe the color charge, which describes a strong force between particles. Alright, well, thank you for watching this video. I do hope that you learned a little bit of something about quarks, particle physics, and maybe had a new appreciation for the field of particle physics. So again, thank you guys. Although, one question is still left unanswered. What is smaller than a quark? Well, that is for you to figure out. You to figure out.